Hey, today I'm gonna show you how to make an interactive street umbrella in Unreal Engine 5. The tutorial includes an interactive system with an interface which can be applied to any object in your game, interaction with umbrella itself, and in the second part you will see how I model, rig and skin and make animation for the umbrella in Blender for people who are interested in full stack game dev like me. This video includes some advanced techniques aimed for better optimization, so it can be helpful for people who already have experience of working with interfaces and interaction systems. First, we need to export a skeletal mesh and its animation from Blender and import them to Unreal Engine. I already had them, so I'm overriding the all files. And when you export a skeletal mesh, you should select both the mesh and the armature, disable the animation checkbox and the add leaf bones checkbox. And when you export the animation, you can select only the armature but should enable animations in the export settings, and you need disable NLA strips and all actions checkboxes. Then in Unreal Engine create a folder for your object. I called it umbrella. In it right click and click on import to current folder. Export the umbrella.fbx, the skeletal mesh. Make sure that the import skeletal meshes checkbox is enabled. Check the nanite settings depending on your needs. I'm importing the texture with the model and I disabled the materials checkbox because I want to make my own ones. As you might see, I have a physics asset. It's an asset where you can find collisions for your skeletal meshes. If you don't have it, right click on the skeletal mesh, create physics asset, create and assign. Then open the physics asset. On the left part you can see the physics body names which your skeletal mesh has at the moment. They are bodies for collisions. Select a needed body and in the right tab you can select the type of the body and regenerate it. Then in the body setup you can adjust its size. Then I selected all the top physics bodies and simultaneously regenerated them as boxes. As you might see, they are turned differently. That's because of the role of each bone. You can set it up in a 3D editor, so I'm going back to Blender. In armature I select all the top bones and in edit mode, armature, bone roll, I click on cursor while the cursor is standing in the middle of them. This will make the roll correct. I exported the skeletal mesh and its animation again, and now when I regenerate the top bodies they lay down perfectly fine. Then I realized that actually I had only half of the needed physical bodies, so I clicked on the gear and selected show all bones. I also have bones called middle, so I select them and add bodies for them as well. Then you can select them all one more time and regenerate all of them and set their size and position simultaneously in the body setup tab. The physical body for collisions is complete. Let's make materials. Right click in the content browser, select material and rename it. Add one more for the second material. In my case, it's a bronze material. It's an easy one. Just set up metallic, specular and color settings as you would like. Let's go into the skeletal mesh file and drag and drop the materials to it. As you can see here, the fabric is transparent from the opposite side. To fix it, we need to go into the material, select the main node and enable two-sided in the details panel. Don't forget to apply and save. Now you can see that the fabric is visible from the opposite side. Let's drag and drop the black and white texture onto material graph. It will be a mask for LERP node. To add it, hold L key and left click on empty space. Connect the texture to the alpha input. Then hold 3 and left click 2 times to add 2 color nodes. Connect them to A and B inputs. Adjust the color. Now, based on your alpha mask, the material will have a 2-color pattern. Let's copy the lerp node for metallic and roughness as well. So the A number is the value for white color in the mask. The B is for the black one. Now let's make the blueprint class. Right-click in the content browser, select the blueprint class and select actor, rename it and open it. In the components, click on add and find their skeletal mesh. Select it and in the details panel find skeletal mesh asset and choose the one you want. In my case, it's the recently exported from Blender umbrella. Select Use Animation Asset in Animation Mode drop-down menu, and if you still didn't import the animation, go to the content browser, right-click, import, select the animation, and in the import settings, make sure that the skeleton is that one which is connected to the right skeletal mesh. Now in the blueprint anim to play setting, you can choose that animation. It plays automatically and is looped. Let's disable those settings. The first thing I recommend to do for better optimization is disabling ticks everywhere where you don't need them to be. In my case, it's the class itself, the rook component and the skeletal mesh component. Then let's create a custom event and drag and drop the skeletal mesh onto the empty space. Pull out from it the set player rate node, where -1 means that the animation will play backward and +1 forward. Pull out the menu from the rate input pin and find their promote variable. It will automatically create a variable for you already connected to the input. Then I decided to make another custom event called play animation and to connect the set player rate node to it, and also to add a simple play node to it. So this is a chunk of logic, a small function which set the direction of the animation based on a global rate variable, and then play it. Our first custom event will be called interact. In it, we will have a flip-flop node. If you interact for the first time with it, it will execute A pin, and if you interact the second time, it will execute the B pin, and the third time, the A pin again, etc. Let's make each interaction set the rate, aka direction of animation. And before it, let's add a sequence node. So we know first it sets the rate and then it executes the play animation event. And the last thing, let's add an E key press event, which will execute the interact node each time when we press E key. In the details of the E key node, remove consume input, and in the class defaults, set auto receive input equal player 0 toward making the E key node work. Drag and drop the blueprint class. This will spawn the actor into the level. Let's test it. Now I'm pressing E key and the umbrella is working, but it's in a beginner level logic. Let's make it advanced. The first thing to do is adding a different sound to folding and unfolding. I already have prepared sounds. I'm importing them just by dragging and dropping them into umbrella folder. Then in the blueprint, I'm adding 2 play sound at location nodes. I am selecting a suitable sound, and now I need to get the location where the engine should play it. For that, I'm taking the skeletal mesh and pull out a get where location node and connect it to the pin. Now I see that I can simplify the code. The rule number 1 is don't duplicate the code, make functions instead. So in the left tab, I click on the plus next to the functions and name the new function. In my case, it will be called play sound. I copy-paste the logic related to the sound from the event graph into the new function, and I connect the sound input to the function node. It makes the input parameter for the function. Now in the event graph, instead of that duplicated heavy logic, I place a simple light-looking function, and it has a parameter sound. For folding pin A in flip-flop, I choose the first sound. For unfolding, I choose another one. Now I realize that play animation event can be a function as well, so I just remove the event and put the logic into a new function with the same name. This decision makes the logic clearer. Let's test it. You probably don't hear because I don't record the sound, but it works fine, believe me. Then I realized that the object still doesn't have collisions. Let's go to the blueprint class, select there the skeletal mesh and find the collision settings. Here I have presets. For example, if you choose block all, Unreal Engine with help of your CPU will check if the object has collisions with all objects in your level. That's heavy, let's optimize it. Let's make our own presets for different types of objects. Let's go to Edit, Project Settings and Collision. Here you have Presets tab and you can make a new one. At the top of the window you have Objects Channels. They are object types in the presets. Let's make new ones such as NPC, items and objects. We don't want them to be checked with anything else except the pawn class, our main character. Because particularly in my case, the NPCs are not supposed to collide with anything except the main character. They will go along as planned and not driven by AI. For simplicity, the objects and items will not collide with anything except the main character as well. They just stand somewhere and no one except the main character can stumble upon them. That's why we don't need to make access checks or collisions. Let's disable them. And don't forget to assign the object type in each of the new preset. So eventually it will look like objects will not have checks for collisions with anything except the pawn, camera and visibility. The NPC and items are the same. And then you should make sure that the pawn preset mutually has checks for the objects, NPC and items. Let's select the new objects type in the collision preset of the skeletal mesh. Let's check it out. And as you can see, it works fine. That's a good approach for better CPU optimization, especially if you build a large level. Then let's make a folder called interaction and there create an interface. Let's name it interaction interface. Open it and make two functions. Name them getInfo and interact. In getInfo function, add an output called info with text type. The interact function will be a simple function without inputs or outputs. Go to the blueprint class, open the class settings, and in implemented interfaces add the new interaction interface. Now in the left tab under interfaces you can see those two functions from the interface. Double click on the interact function and it will appear on the graph. Now we can connect it instead of our custom event called interact. Also go to the getInfo function and here you can enter something like interact with umbrella. But I want to make it better. Let's duplicate the return node and in it open the umbrella, in the other close it. Let's make a new variable with type boolean called beOpen. Then with branch node we can make the return of the function different depending the beOpen variable is true or false. Now let's make the variable dynamic. In the interact logic, we will change it at the end of the interaction. We can pull out not boolean not from the boolean variable, which will reverse it, and then save the new value to the variable itself. Then I just change the order, what does not really matter, but make the logic more understandable. Then go into the bopen variable and in the details panel set its default value equal to true, because our umbrella is open by default. But what if we want to have ability to change its default state? What if we want to place objects with the same class somewhere open by default, somewhere closed? Let's make it real. Replace the flip-flop node with a branch node connected to the bopen variable. Then go to the construction script. That's the place where we program the default initial state of an actor. Don't forget to make the bopen variable open and editable by clicking on the eye, so we can change this variable in each umbrella actor in the editor in the details panel later. Based on the open variable, we will override animation data of the skeletal mesh. I decided to make the flow a bit better on my taste, so I'm adding a sequence node and connecting the override animation data to the last pin. I'm choosing the animation we are playing and everything other. Then in local variables, I create a new variable called position, and depending on the open branch, I set it equal 0 or 1. And I connect it to the override animation data node. This logic sets the initial position of the animation. Either it's 0, what means unfolded, or 1, what means folded, the end of the animation. Then I'm noticing that actually the end of the initial position in my case is 1.2. So I'm changing the value in the construction script. Now let's test it. So you can see that I can change the state from open to close, tweaking the open checkbox in the details panel. Let's reconnect the E key node to the main logic temporarily for testing. Now you can see when I press E key, both of the umbrellas do a bit different action based on their initial state. But I want to interact them individually. That's why we needed the interface. In the interface folder, create a blueprint actor with actor component type. That will be a model which we can integrate anywhere later, but in our case it's a model for our character. Let's name it Interaction BPC. Open it and disable ticks there. Create a function scan, which is going to find an object with which we can interact then. In advance, in the event graph, event begin play node, you should get owner of this BPC. In our case, it will be the main character, and out of it, you can get a component by class. The class should be a camera component. So, we want to get our camera, and also we should save it in a variable, so promote it to a variable. Event begin play node is the one which executes at the very beginning when the game spawns the actor, in our case when the game spawns the main character. Then you go to the scan function, get the camera component, pull up from it its world location and forward vector. I'm going to print them to show how they work in case you don't know it. But before, we should integrate our new BPC into the third-person character class. To find your character, you can go into the world settings panel and there find default punk class and click on the folder with the magnifier. Open the class of your character and in the components panel, click add and find there your interaction BPC. Compile everything, and the last thing, you have to initiate the scan function in the BPC. For that, go to the interaction BPC and in the begin play event, add the set timer by function name node. It will execute a function with the name scan in a loop with a 0.2 seconds interval. When I run the game, I see for each 0.2 seconds. One line is the world location of the camera, another is where it's turned to. A vector consisted of values from -1 to 1. Let's remove the location quickly. Now you can see how the direction is changing. It's a vector which begins at 0, 0, 0 and ends at the value between -1 and 1, given an arrow in space pointing to where we look at. If we multiply it on some distance and then add it to the camera location, we will get the end of a line going from the camera toward the center of the screen. We need that line to check if it collides with something using line trace by channel node. One more time. We will have a line in the whole world space consisted of 2 points, A and B, and the line will have length. Point A is the camera world location. Let's make a scan float variable for the length of this line. Let's multiply the forward vector on the length so we get a long vector instead of a clumped from -1 to 1. And then we add that vector to the camera world location. It will be our point B, aka end of the line for tracing. You can quickly enable debug visibility of the line and ensure that it works fine. In my case, I decide to add also the length of the camera boom spring arm to the length of the trace line. You can get it the same way as you got the camera. Get its length and save it in a variable in the event begin play, and then add it to the scan length. Then I break the out hit output and pull out the info about the collision if it happened. Also, I have return node, which is going to be true if collision happened and false if didn't. With the branch node, I am printing collided and didn't based on the return node. Let's test it. As you can see, it works perfectly fine. The next thing is the trace channel. You can apply custom trace channel to any objects types in the collision presets. So this node will check only the objects which have this trace channel enabled. It even will not check the other objects and will collide only with special ones created for interaction. Let's go into the settings. Let's add a new trace channel. By default, it will be off everywhere. Then open the preset which you want to make interactive and enable there the interactive trace type. Make him block. In my case, the interactive things are objects and items and NPC. In the line trace node, select the new trace channel. If you don't see it in the list, recompile the class and it will appear. Let's test it. As you can see now, it prints didn't when you had the rate over regular objects. But if you aim at the interactive object, it will say collided. That's what we need. Now pull out from hit actor output does object implement interface node and choose there our interact interface. If it does, then we're gonna save the hit actor into a variable. For that, promote a variable from hit actor and connect it to the true of the does object implement interface branch. Then we're gonna make the variable equal none, aka empty, if the object doesn't have the interface or if there were no any collisions with interactive objects at all. In the event graph, add the key event, take the actor for interaction variable, check if it's valid, not empty, and if it's valid, run the interact function of the interface connected to the particular actor found by scan function by pressing E key. Disable consume input in eKey event and run the game for testing. As you can see, it works perfect. But eKey event is a bad approach. Let's make input action and input mapping context for this function connected to eKey. With them, you will be able to change the interaction key in the settings of the game, and also the logic will become modular and professional. Rename them, go into input mapping context and add the input action we made and assign the key there. Also go into the input action and add the trigger pressed. Otherwise it will get fired not once by pressing but multiple times by holding, and this is not what we want to have for our interaction function. Go into the controller file, perceive it as the class above the pawn. Everything you add here will apply to all pawns, such as the character and the vehicles if you possess them. So if you want to add a key only to a certain pawn, do that in the pawn class, not a controller. Take the enhanced input location player subsystem node and add mapping context node, copy paste them and select a new mapping context we just created called IMC Interact. Check if there is no interference with the main default mapping context, because some assets already have interact input action, for example the one from the game animation sample with parkour features. In the interaction BPC, take the input action and replace the event with it. The next thing we want to have is the info widget, which appears when we are focused on the something we can interact with. For that, make a new widget blueprint. This is a class for user interface, and there select the user widget. Call it info widget blueprint. Open it, add there a border which will be a background for the text, and then as a child add a text to the border. Enable isVariable checkbox in the text to make it a variable which can be dynamically changed. Then go into the border, set the color and set up alignment of its content. At the top left corner you can select desired on screen instead of full screen. It will allow you to see its real look. Then adjust the padding of the text. As you might know, padding is empty space around the object, in our case around the text. You also can change the initial text of the text component in the details panel. Then you should have a HUD widget, the widget where you're gonna have all small widgets together, such as health bar, info about money or anything else related to the game. Make just a regular widget for that and call it HUDWBP. In it, add a canvas panel so we can make a layout for different small widgets. Drag and drop the info widget on the canvas panel component. In the anchors, you can select the place of the origin from which the position of the subcomponent will be calculated. In my case, is the center of the bottom screen side. With hold Alt key, I should click on it and then make positions equal 0 and adjust alignments, then make the position Y a bit smaller than 0 to make a constant offset from the bottom side of the screen. Now we need to show this widget to the player. First we need to create it, aka spawn it. You can spawn it either in the controller class or a pawn class. I do that in the pawn class, the character class, because in this case it's easier to switch between hoods in different pawns, such as vehicles and characters. In the event begin play node, create a widget and select the HUD WBP. promote it to a variable, and add to viewport. Run the game for testing and you should see the info widget now is on the screen, but not dynamic yet. Also, let's make an IM widget as well. Make a new widget, add a border in it, go into the HUD widget, drag and drop the IM widget to the canvas, set its position and size there. Run the game and you can see it. Go into the character class, select the camera boom and adjust there the socket offset so we can see the character a bit from the side. Now it looks better. Let's get that info widget into interaction BPC. For that, get the owner. The engine doesn't know what the owner is, so try to cast it to the needful class. In our case, it's the third-person character class. If the cast is successful, the engine will understand that the owner is not something generic anymore, but a certain third-person character class. So, from it, we can access all third-person character class variables now. Let's take the HUD WBP, pull out from it info WBP and promote it to a variable, aka save it in memory. In the scan function, drag and drop that variable and get the text variable called info. Then set text in it. From the actor for interaction, pull out the getInfo function of our interface. It's supposed to send something like open the umbrella or close the umbrella or anything other info related to the certain actor. Here we could connect them, but I realized that before any info I won't constantly have press E2. For example, press E to open the umbrella. That's why I removed this small chunk of logic and I'm going to info widget blueprint. There I create a custom event, aka function, called setText. I take the info variable and set the text as we just recently did and connect the pink text in to the event to make the input for this event. Disconnect them and pull out a format text node. The text will be connected to 0 node, and as the base I'm gonna have press E2 with 0 in brackets, what means that everything from the 0 input will go into the place of the 0 in the brackets. Then in the interaction BPC I already pulled out from the info widget variable that event, and now I'm connecting this info and text pins. In the HUD widget class, let's make two custom events for making the info widget visible and hidden. For that, I use setVisibility node taken from widget variable. In the event preconstruct, let's use the hideInfo event to make its initial state hidden. In the interaction BPC, let's also save the HUD WBP by promoting the variable. In the scan function, let's call the showInfo event each time scan finds something interactive. And let's hide the info when there is nothing to interact with in front of us. You can see it doesn't work and there are many errors. It's because in the interaction BPC we try to get the HUD and the info widget before the third-person character class has managed to create them. So let's add a very short delay on the begin play logic of the interaction BPC. As you can see now, it works perfectly fine and the interaction BPC can get the HUD and info widget because of that short delay. Now the problem is that it executes the hiding and showing of the widget literally each 2 milliseconds on each scan. And that's not good in terms of optimization. I want to make it change only when we move the IEM to something different. For that, let's make a check if the new scan result is the same as the previous one. Let's make a new boolean with name something in focus. Let's make an info variable with text type. Let's duplicate it and call it previous info. Let's save the current info and then let's get the previous one and compare. If they are different, only then let's change the text in the info widget. Then let's save the value of the does object implement interface in something is in focus variable. It literally means if it detects the object with that interface, it means that something interactable is in focus. Let's make a new boolean variable called something is in focus previous. Then we are going to make a sequence, so at the end it will save the current info and current boolean as previous ones for the next iteration. Then I'm going to make a simple logic. If something is in focus now is false, was it true in the previous scan? If it was, it means the IEM changed. The state of focus absence is fresh. Let's hide them for then. Now remove the old chunks of logic here and here. And now I see that the function looks overloaded a bit. I decided to make a separate function for the line trace coordinates. I'm calling it getScanVectors and cut the logic from the main function and place it in the new getScanVectors function. I'm connecting the vector to the output node, make a new local variable for the scan length and put the function into the main logic. As you can see, it has flow pins. I want to make it without them. So in the function, I enable pure. And now the node is green without access pins, just with the info about the start and the end of the trace ray. And the logic looks clear and neat. We only need to remove the show info node at the end and place it here after a similar but reverse check-in. And now let's quickly add descriptions of each part of the logic. So if you still don't understand how it works, you can read the description and it will help you understand the meaning of each chunk of the logic and how it works. And then let's run the game. As you can see, it still fires the function many times instead of once. And it's because I mixed up the places of these two variables. A very small mistake. So I have fixed it and let's test it one more time. And it works perfectly fine. Now you can use this system with any objects in your level. Just add the interact interface to a class, add info into getInfo function, set up collisions and make the logic for action when you interact with the actor. That's it. Thank you for watching, and the next video will be about how I make the skeletal mesh umbrella in Blender to be able to interact with it in Unreal Engine, so as we just did it.